Alright, we're going to start here with a introductory video to how to build your own Hydrautomat. This is going to be a series of videos on how to make the fittings for and just about everything you need in order to make the Hydrautomat. We're going to go through how to, what each function of the Hydrautomat is, which each function of the tanks are and stuff, and how they work to eventually create, the action that the Hydrautomat creates to pull the water up. From the feed tank all the way up to the reservoir tank. I'm going to show you the parts, like the fittings and things like that. We're going to show you how to make the parts and things. We're going to show you how to make the components of the Hydrautomat, which are the different tanks and things like that. This right here, as you can see, is kind of an old component that we're not going to be using in the latest version of the Hydrautomat. This is kind of an older version right here, and we're also going to show you where they go on the shelf. So we're going to show you where each and every one goes onto the shelf, where they drill the holes for the shelf. I might also upload some schematics on where to drill these holes and reference to everything, so that you kind of have your own plans and stuff. Might do that, and I'm going to show you also where they are, where they drill them, and then also what they look like when they're fully installed, so you can see where everything looks like when it's fully installed, and any kind of tips and things like that. Some like probably hanging the tanks, or just where everything goes. So we're going to go through all of that stuff, and you're going to know exactly how to make everything that you need to for the Hydrautomat, where to get it, what to use, what dimensions to get the tubes and cut the holes and all those other things. And by the time you see all this stuff, you'll be able to create your own Hydrautomat and hopefully improve upon it and make it even better for the rest of the world. Alright, we're also going to do a quick video here just to give you a bit of a background as to what used to be done and what we're going to be doing now. What I used to do, basically the typical technique that I tried to do with this thing, which wasn't really good, is kind of improvise and whatever, was to take like a quick connect fitting, because I figured that would give me a lot more, I guess you could say, flexibility with this, because if I used to use a quick connect fitting because I figured I could just take this vinyl tubing, cram it into here, and if I ever needed to, I could just push the ring and pull it the heck out. And that didn't work, so what I used to do is I used to put this caulk on it to keep the water from leaking out of the thing, because the thing will leak. And to keep it in place on the other side, what I do is I take like a coupling or something like this and cut it in half, because I didn't need a full-on coupling that would be standing up like this. And I just screw the thing into the bottom like that, and it was a bit of a mess. Usually the reason why I would do this is because bulkhead fittings that I didn't really search around for bulkhead fittings at the time, and bulkhead fittings were expensive. They were like $7, $8 a piece, and I just did not want to spend that kind of money for it, so I tried to cheapen it up by doing this. And this didn't work out very well. It leaked a lot, wasn't very useful, and if this thing ever got strained or something, and even so much as a pinhole was created in one of these things, forget about it. And also, if you didn't properly put the caulk on this thing, it would leak too, and that wouldn't be fun at all. So that was one problem. The other problem, that's just an example. Well, the other problem with the original Hydrautomat was the tiny little tubes I used to use. I used to use these 1/4-inch pieces of vinyl tubing, 1/4-inch OD, and it's like 0.17 inches inner diameter, and it would just take forever for it to fill up. So so what I decided to do instead is now with the new Hydrautomat, we're going to upgrade it to a 1/2-inch OD outer diameter with a 3/8 inch inner diameter. So it's a lot bigger, as you can see right here. It's a much bigger size, a lot greater water flow than what it used to be. And that's what I'm going to be doing this time. So that's kind of the historical outset of things. You can see the like the feed tanks and stuff. That would change a lot. You know, the feed tank was hard to fill, so that's why I came out with this input tank, and that would take forever to fill up the feed tank, because at least this was easier to put a garden hose into. But I also changed that around with an automatic water feeder and stuff, like you saw with probably some of the last Hydrautomat videos. So that, you know, it's a work in progress. I mean, you go from something like this to the giant tank with the automatic water feeder on it. So that's pretty much the whole recap of what used to be done. You know, things just were not good at all when they first started out, but it was a start. And yeah, so now we're going to go on to the next video on what we're going to be doing for the fittings. I'm going to show you how to make your own fittings with this thing, using bulkhead fittings and barbs, mainly barb fit. You know, always use barb fittings, and from there on out. Alright, so for this section of the video series, what we're going to show you is the function of the Hydrautomat, as well as how it applies to the actual Hydrautomat. So this is probably the best way to explain everything, is just by showing you the actual original patent, which even the actual patent itself doesn't really look like that in real life as it did in 1927, I guess, but this here shows the fundamental concepts of everything. So what we're going to do is we're going to explain what each and every tank is, and where the hoses go and things like that. As you can see, they're a little cramped together, unfortunately, so it's kind of hard to exactly point things out. I don't know, maybe I can use this to point things out and try and show you the best I can that each and every hose does. But anyway, we're going to show you the tanks, we're going to show you the hoses, and we're going to show you the function of this whole Hydrautomat, what everything does. So it's probably going to start out right here, showing you what the feed tank is. Showing you where the tanks are first. First I'll show you where the feed tank is. That's this one right here, marked G. And that's where the water comes in right here. This right here, this little line you see right here, that's a high water mark. And right down here is a low water mark right here. So this right here would be just like, you know, a river or something like that. And this right here where it would fall would be like downhill some distance or whatever. I mean, you could have like a dam or something like that. So you could have a dam wall, like have like a dam or something like that here, and the water would feed into this, and this here would be on the other side of the dam where it's lower, or something like that. Either way, you need a differential of water level from the high mark here to the low mark. That's where your differential is, and that allows it to raise up higher. And with something like this, you can depends on the dimensions. The original Hydrautomat was like 8 feet high, and it could lift water like 15-20 feet. So it all depends on the dimensions of it, as well as the volume of the operating tank, and so on and so forth. But first I'm just going to explain to you what the tanks are. So this here's the feed tank. This here's the operating tank. I guess I forget which is the head race and the tail race, but I do not like using those terms, head race and tail race. I would always use stage. So this is the first stage of it, second stage, third stage, then reservoir. Right here, this is actually called reservoir. I don't know what the head race and tail race is. I don't even know what a race is. So this is such an archaic term that from now on I'm just going to be using the term stage. You know, like a multi-stage rocket. You know, you got the first stage, you know, and then as you get higher into orbit, you get the second one, and so forth. Same thing here. And showing the other components here, we have the air tube, which is right here. We have the siphon. We have this little switching device right here, which is also hooked up to a valve by an eccentric gear. And we have the also have a breather tube here too. So first going to explain what the tubes are. This right here is what I call the feed tube. I don't exactly know what it's called. It might be called a feed tube right here, and that leads from the feed tank into the operating tank here. Then you have a siphon, which is this right here. And as you can see, the siphon consists of both the siphon, which is this tube right here, as well as a trap right here, so that when the water in this fills all the way, not fills up, but drains all the way out, what happens is that this won't suck back in through here. So if you just had a pure siphon that would come like from here out to here, when this thing ran out of water or whatever, it would probably just want to suck back up through here. Instead, that's negated right here by this trap. So that's what the traps are for. That's what these U's are. When you ever see U like this, that's a trap. And when you see something like this, this is typically a siphon or something. So that's what those hoses are for. This is the air tube right here. And this is used to pressurize as well as create a vacuum. So you can use positive pressure, which it pushes down on things. And you can use negative pressure, which sucks on things. Right here, and that's the tube to convey that to these tanks. And it starts from the top. Right here, so it deals with the air pushing on the water, or the air sucking up, and then it sucks the water up along with it. And I have these tubes right here, which are the input and output tubes. The input tubes always go out through the bottom. You always find an input tube on the bottom of the tank. It's just usually a fitting or something to connect the bottom of the tank to the tube. Goes out like this, up through here, and then goes to a tall pipe at the top. And as you can see here, it's kind of like a dome or something like that. That's cute. You see this little dome here where it's like that? That's probably just to make extra room for this pipe here going up at the top like this, and kind of maybe to avoid the air tube or some kind of function like that. Maybe it's listed in the patent there or not. I don't know. I haven't read the whole thing completely, but I know how the whole thing works. So there's just this is trivial anyway. I mean, you don't really need something like that. So anyway, you have the input tube going up through here, goes out through the hose here, and the reason why you have it so high is that if this was connected directly at the bottom and the wire would just spew out, as opposed to going a little bit further from the top here, what would happen is all the weight here in this tank, or most of the weight, kind of in like a V shape, all that weight would just be pushing down on this tube here, and you have a lot of back pressure pushing back down on it, and make it harder for this to push upward. So what you do is you just have a tube going up through here, so that what happens is the water just, it might resist the tube, but the tube, resists that water pressure there, and it doesn't impede the incoming flow. So what happens is the water can flow up here freely, only having to resist the weight of itself, of the water through the tube, rather than the water of the tank, and then it just goes out through the top and falls down, like that. So that's how your input tube here works. And you have the output tube, which is same thing as it was here with the feed tank. It's located at the bottom, goes up through here into a tall pipe again. Same thing here again, and then same thing here again, and it just falls into this reservoir to the top. The reservoir is open to the air, and same as this right here. This second stage here is open to the air, and yeah. And the only difference I would have to these two tanks right here are closed off. These are not exposed to the atmosphere. These right here are completely closed off in a vacuum, I guess you could say. They're totally sealed off, so that when there's suction, it doesn't pull air from in here and breaks the vacuum. And it can also pressurize so that you don't have leakage going out through here. So that's what this is all about. And this right here is a breather tube. As you can see, it runs here from the bottom of the tank, nearly the bottom of the tank. The tube runs up directly out through the top, in through the bottom, and then out through basically just above the tank here. And this will pour out through here. Now the purpose of this is that during the pressurization cycle, when this thing is filled with water, when there's pressure here, it pushes it up through this tube right here, and it just pours directly out, as opposed to having to go through the trap. Instead, it can just go make a beeline right through the top of the tube, the tubing here, or pipe, or whatever you're using. And this right here is a close-up of the top of this thing right here, which is actually a check valve. This is kind of like a either homebrew version or whatever they used to use back then for check valves, but that's exactly what this is. So the wire can be pushed out, but what happens is when there's a vacuum, this door here, instead of being pushed out, it gets got tongue-tied there. It gets sucked back in like this, claps shut, and closes, and doesn't allow any air or water to go back through into the system and break the vacuum. So it can only go out, but not back in. So that way you can just push it out, and then when it's on a suction cycle, it closes, and nothing breaks the vacuum here. So anyway, I'm going to go now through the function of this thing. to show you exactly how this works. You have the feed tank here, which has the, and usually what happens is that this switch here, as you can see, there's a counterweight here, and there's a paddle, and then there's this little fulcrum here, so it's on a lever system, and this whole lever here is hooked up to an eccentric gear, and it's hooked up to a valve. Now normally, this right here is when it's in operation, when the siphon's activated. When the siphon isn't activated, what happens is this counterweight takes over, and the counterweight's down here, and this little switch or paddle or whatever is up here where this siphon is. So what'll happen is this will be open. So when this is down, this here is open, and when this is up, like you see here in this drawing, this right here would be closed, because you can see this is all full and stuff, and this is empty, of course, with air. So what happens here is that this fills with water. The switch is open here. This would be down, and this would be up. This would fill up with water, and eventually start filling and filling. This would get filled with water, and this would fill up along with it. And what eventually happened is it would start compressing the air in here. This would fill up here, and the water would start to fill up, and then eventually go out through the siphon, because this right here would become compressed. And also, even if this wasn't compressed, the water would still fill up to here, go up to the top of the siphon, and then go back down like this, and then would press this little switch here. That would be, the switch is down here right now in this illustration, but when it's filling up, it would be up here. Sorry about that. And it would just go down, push the switch down to place the weight of this counterweight here, push the counterweight up, and also push this lever up here by the eccentric gear you see here, and push this up, and then we close the switch. Now what happens is normally when this thing's draining out, what would happen is the water from this feed tank will go up through here and then go out through here. But since this is all closed off, no water can replenish in this. So this is in a sort of a partial vacuum, and it's constantly draining out through the siphon. So by hydraulic pressure, by hydraulic action, what happens is this slowly goes out like this, and it kind of acts like a piston made out of water. It's like a fluidic piston is what it really is. It's very interesting how it works. And it goes down like this, and you have this finite amount of air right here that's being sucked, that's being pulled on. Because what happens is this is going down here, and you have to have something to replace that. You have something to take the place of this water as it goes out through the siphon here. So what happens is the air gets sucked up along with it and creates a negative pressure, creates a vacuum. Now when that happens, this right here, this tube is still open. So this becomes a negative pressure right here, and this becomes a negative pressure. So this area right here, the pressure becomes less than this here, and eventually it's kind of like reversing gravity or something, and it just sucks it up through here, because the water is heavier here than it is, then the pressure is higher here than it is here, and the water gets sucked up into the top here. And what happens is it won't directly suck up through here unless it's like right next to it or something, or it's a really high vacuum, which doesn't happen with this device as it is now. And what it does is it just falls out, gets to the end of the tube, falls out, and then deposits here at the bottom of the tank, and also fills up this trap as well. And it just slowly fills up as this thing drains out. Now what will happen is this operating tank only has so much water in it, right? So what it'll do is it'll go from the top to the bottom, and eventually there'll be so little water in this thing that the siphon will stop moving. The siphon will stop working here. The water will turn off basically. It'll go back up through here, and a little bit will go back into the operating tank, but the rest of it will sit here in this trap as well as the bottom part of the tank. And since there's nothing coming out through this siphon here, what will happen is this switch or paddle tray, whatever in the world this thing is, will go up, because what happens is this counterweight is still bearing down, and there's nothing here to counterbalance the counterweight or whatever. So the counterweight will drop down, this will go back up, and as this drops down, it pulls this lever here back down, this eccentric gear, I guess that's what it's called, and it pulls this down and opens it back up again. So what happens is this water goes here, kind of replenishes that partial vacuum, and it pushes up on the air again. And what happens is as this thing fills up, the piston pretty much made out of water, I guess you could say a water piston or something, is essentially what this thing is, goes back up again, and then pushes the air back down. Pushes the air back into these tanks. Now the tanks are full with water, right? So what will happen is that the water will be pushed down, instead of going down into this feed tube here, which as you can see you have partly you have this right here to resist against that. So what happens is the water will be pushed down into here, because the water level is above these tubes usually, and I'll go up through here. And also on my device I have check valves here too, to make sure there's no backflow going back from this tank into this tank and from this tank into this tank. So anyway, on the pressure cycle of this thing, this air pushes down on the water, pushes it back down, and instead of going through the feed tube where it first came out from, it goes out through this trap and up into here. So the pressure becomes higher than here, and it pushes it up. And also there's this breather tube here, and the way this works is the pressure is so high, pressure's higher here than it is here, and it's a path of least resistance. It's an easier way for the water to go up through this breather tube here than it is to run the whole circuit all the way through the, not the whole circuit, but run the whole path from this trap here all the way up to the top. Instead I can make a direct line to here, and when it gets back to the suction cycle again, you have this check valve here to make sure there's no backflow, so that the water in this tube doesn't flow back into here. So that's how this first stage works. Now the third stage is pretty much the same thing, so that when this thing's going down again, what happens is you have the vacuum, and it pulls the water that filled up from the pressure cycle, so the pressure cycle pushes it down into here. This tank fills up, and then on the next suction cycle here, the suction in this tank and this tank sucks the water from here up into here to replenish this tank that was drained out by the pressure. And then also, since this tank is now full, this right here creates a vacuum and sucks the water from this tank here out through this tube and into here. It fills this one up. Then on the next pressure cycle, it just pushes it back down and out into here. So it's just an alternating water staircase, I guess you can say. They called it that back in the 1920s, a water staircase. It just makes its ways up and eventually into here. And depending on the volume, as well as the drop of the siphon right here, depending on the volume of the tank here, they have the operating tank and the length of the siphon, which determines how much you can pull on this thing. Depending on that, you can actually extend it up to even more stages. Or alternatively, you can couple it with more stages, and you can also just stretch the stages out more, so you have more distance between this tank, and so on and so forth. So that's basically how this thing works here. And now I'm going to pause this video and move on to how this thing works in real life. Alright, now we're going to start with how this thing actually works. How the principle I explained in the previous video with the patent works with the actual device. As you can see, it's all fully assembled here. First thing that happens is that this thing fills up. This would be like, a higher water marker would be like right here. For the device, to make things easier for myself, since I don't have a river nearby that I can run like a pipe or something into. Instead I have this automatic water feeder with a garden hose, with a piece of tubing coming out with a little garden hose adapter to it, so that the water would go up through this tube here, out through this automatic water feeder, and it would fill this thing up. So once it gets to a high enough level, the little feeder turns off and keeps it from overflowing and wasting water. So anyway, this would be the feed tank here, and this would be the operating tank, and this would be the first stage. So what happens is the water from this feed tank goes out through this tube here, runs down, and there's a bit of an adaptation that I made. I'm going to show you exactly how this whole thing works. About right there. Be a good angle. So the water would flow by force of gravity down through this tube here, into this drain tank here, which contains a kind of like a substitution for the lever switching device that you saw in that patent. And what happens is it goes through a little float switch here, and goes up to the top and into the bottom of the operating tank. And as you can see, in the operating tank we have an air tube here at the top. We have a siphon, which you can't exactly see. It also runs out through the bottom here, goes up through the side here and out through this right here, and then goes down into the drain tank again, which is a triggering system. You can look at my, you just go to the drain tank video under where the components and stuff are. Just look for the drain tank video and explain everything there on how this whole switching device works. But it's the very same thing as what Thomas Gaskell Allen was doing with his device, except this is a pulley instead of a lever. And this right here is to make sure that the thing doesn't, sometimes when this thing fills up, there's still some pressure or whatever, and forces the air prematurely out through the siphon before this thing gets filled up. That's what this is to stop. I just keep this on here. It's an optional thing. So anyway, we have the siphon here, and this thing will fill up to the top, and the water will fill up through the siphon here. I'll go over the thing will fill up to the top, the wire will go up through the siphon, out through the top here. Eventually it'll get to the very top, go out through here, into the end of the siphon. It'll trip the switch will turn off, the flow going, turn off the switch, you'll close the switch in this tank, and there'll be no more water. The water won't be able to flow from the feed tank into the operating tank. This whole circuit will be closed off. So this right here will just keep on draining out through the siphon, and as it keeps draining out through the siphon, want to see where we are. What'll happen is the air right here will get sucked down by the operating tank. The water level will drop, and the air will get sucked down by that kind of virtual piston action. It'll create a vacuum through here, pull the air back, pull down the air through this air tube here, which also runs this T. And the air tube runs through the top to the first stage here, through the top of this thing, through this tube right here in the back. And also the air tube runs up here through the top into the top of this tank right here. So this will be the third stage, this is the first stage, and this is the second stage. And that's the reservoir at the top. So that's what creates the vacuum action. So as the air is sucking down like this, what'll happen is this will be closed off, there'll be a cap on here and everything. And what it'll do is it'll create a vacuum, and the water in this feed tank here will get sucked out through this tube, get sucked upwards through this tube right here into the bottom of this tank, and go out through the tube that's in the center, in the back of this thing that runs up to the top. So the tube's about this high, and this tank here will flow out through the tube and into the bottom and slowly deposit and collect. So that's how this thing works here. Very same principle. And then when this thing gets to the top, this thing gets to the bottom, what it'll do is the siphon will turn off, counterweight will drop again, and then it'll fill back up again because the switch will be open. The counterweight drops, the switch will go down, this thing will open up, the water will fill back up again, and then it'll create pressure, positive pressure on the air line here. And then the pressure will push down on the water inside this tank here. And what it'll do is it'll push the water up into this tank here through this tube. So it'll push down through this tube here. And there's no fitting on the inside of this tank. There's only a fitting right here on the bottom. So what happens is it pushes it down into this tube, goes up through here, and it goes up to this tall tube here with that check valve on here. There's a check valve. I would say, how there's not a check valve here? I'm confused. Oh, here we go. There's getting confused with the tubes too. There's a check valve right here to make sure that the water can only go up into this tank here and out to the back, not back down into here. Same thing with all these tubes. They all have check valves on them. All the tubes from here to here to here to here and to there, they all have check valves in them, except for the air tube because it needs to go back and forth. So anyway, the water runs up through here, and it's out through the end of this tube right here, and then deposits in the bottom and slowly fills up. And then what happens is this would be filled up here at the top. And this would fill, this would fill to the top. The siphon would fill up again, go back down, depress the tray, move this counterweight up. You can see the counterweight. I think you can. Not exactly sure. Yeah, you can kind of see the counterweight. And that would pull the counterweight up. Tray would go down. This would close off again, create a vacuum as it drains out through the siphon. And as that vacuum is created, what happens is that both of these tanks are under vacuum, as it was in the beginning, but now there's water in this tank here too. There's water in these tanks, and there's no water in these tanks, or at least there's a little bit of water left in this tank here from the previous cycle, from the pressure cycle. So what happens is the vacuum pulls the water up into here, so that this tank here is pulling on the water in this tank, and this tank here is pulling on the water in this tank. So these two tanks suck the water from the tops here up into here. And then on the next pressure cycle, the water from this tank is pushed up again into the second stage, and this tank right here gets pressurized and pushes the water up through here into this reservoir. And also to show you, the output tube here is the back, goes up through here and up and through here. So then on a suction cycle, that's where this tube does. And the breather tube runs a direct circuit. If you're wondering if I skipped that, no, sorry about that. Breather tube is the one right here that's dangling down. It's touching the bottom here, but it's not closed off. It's the tube here. I don't think you can see it, but it's at an angle. So what happens is that it kind of square at an angle so that there's it can suck the water up into it. It's not laying flat like this, because then you would have a possibility of creating a vacuum. It's like this, so you have some water you can suck up through it, or you can cut the tube a little bit if you want to. Anyway, so that when this thing gets pressurized, the water would push up also through this tube, as well as through the other tube here, so that this would pressurize it directly up through here and up into this tank right here, and then out through this check valve here. So that when there's a suction cycle, this check valve turns off and it can't run back in here and break the vacuum. So that's how the whole device works in practice. And just always make sure that you have barbs and stuff like that. When you're dealing with like soft tubing, always use a barb as opposed to what I used to do with the quick connect couplings. As you can see, this thing right here is in an S. It goes up like this. It doesn't actually have to do that. What it needs, the only reason why it's running like this is that I didn't want to make a really tall shelf and then take this thing and put it up on the top here and have the third stage run up to the top. It could do that, but the problem is that it would just take, the thing would be so humongous. I mean, it would be taller than where the basement is. So I had to run it down through here. And also another reason why this is so long is that I don't want to I don't want the tube to kink. So I have it run this large amount like this. But in theory at least, this tube would just run directly up into the bottom of this thing and out to the top of the tube that's located inside of it or just above it, so that when the water runs out of the tube, it falls into the container. So that's the actual method of how this thing works. Give you a little bit of an idea here too on how this drain tank and stuff works. When this siphon drains down into a fitting that's right here. I don't know if you, hold on, I'm going to put the LCD here to make sure. Yeah, okay, you can see it. Goes through here, so the tube is running through here, across into this fitting here, drains down into here, and there's a tray here at the bottom, and that's what depresses this little float switch here that determines whether it's on or off. And the float switch is upside down, so things are inverted and it can work in this purpose. So the water will flow down and push this switch down here. As the water collects in that tray, it becomes heavier than that counterweight and it can pull it up. And then when the water drains out through this tray here, which has some slits at the bottom of it, what'll happen is the counterweight will take over and pull us back up. So that's how this thing works. And as for if you're wondering, okay, that does that, but how does the wire get out of this thing? There's also this little fitting here too. This should actually be a barb. This is a quick connect fitting here. Do not use this. This is just because, you know, I carried over from when I was first experimenting with things. Make sure you use a barb fitting on this thing along with a bulkhead on it. So you have a bulkhead on the wall and you have a barb fitting at the end of this. And that can run out to wherever. I'll explain that in another video about the drain tank. So the wire will fall down here, fill up to a certain amount of height, and then it'll just drain out through here without interfering with that switch. So that's how this whole thing really works in practice, and does pretty much the very same thing as what Thomas Gaskell Allen's patent does, how his Hydrautomat works, except instead of having a little lever here with the counterweight and stuff like that, we have a pulley system. And instead of the instead of having this little switch here and stuff, having this little valve at the top, it's located right here is where the switch would be. And this right here would feed in and push a lever down, and the switch would be right here. And the counterweight would be a pulley system. So that's how that all comes together. So now we're going to go on to the next thing, which is not exactly sure now. It might be the fittings or something else, but we'll see next. Now what we're going to do is we finally got some fittings, which are proper type. Got these from McMaster Carr. These are 1/4 inch barb to 3/8 inch, 3/8 inch barb to 1/2 inch thread. So what this right here enables us to do is to screw them into here, into the bulkheads, as you can see right there. And the 3/8 inch allows me to put in a 1/2 inch OD tubing into these things. So we finally have the proper fittings or whatever, and it comes a lot faster than it does from Amazon.com. So what I want to show is a little technique I just came up with, which is to clamp this little piece of plastic here into this vise without deforming the thread, because the thread, especially that's plastic, even brass, can easily be deformed and ruined by the pressure of this vise. So what we're going to do is we're going to use this red gasket rubber here. We're going to put it on either side like this. Put that there, make pretty much a sandwich of sorts. And what we're going to do is we're going to use this, what you call it? Going to use this fitting, this bulkhead fitting here. I'm going to put this in as it is right now, because the reason why I'm going to be putting this fitting in here, as opposed to putting in later, like you would see right here. Later you can screw in the fitting on here real easily, but when you need to put something on the inside, it's a lot more difficult, as you can tell. So what I'm going to do instead is I'm going to put this in beforehand and then insert this in here, so that when we have the input tubes, or the tubes going inside this thing, like you see right here where it goes up into the tank, we can have that fitting there sitting on the top with the tube going into it, so it sticks up, you know. Okay, that wasn't a cell phone or something. So it sticks up like this into the tank, instead of having to screw it in there after everything's all said and done. And another thing we're going to use before we embark on this little operation here is we're going to use some Teflon tape. And I highly recommend you use Teflon tape, because just because it's brass onto plastic doesn't mean that it is going to have a watertight seal, and if anything it won't. Because I've seen that happen before. I've seen that with the drain tank, even right below me. The drain tank itself will also leak, and that's just the, and the only pressure on that is just the weight of gravity pulling down on the water. That's all. That's only pressure that's encountering. It's leaking even then. So what we're going to do is we just put a little bit of Teflon tape on there, wrap it like 2 or 3 times. We just want to, might be overdoing it a little bit, but we just want to make sure we do that. And whatever you do, don't let go of that, because when this thing unravels, it's a real nightmare. So we're going to take this, snap it like that. It's pretty easy to snap off. Be careful in how you let go of this thing, because Teflon tape's a nightmare when it falls. And then we see this right here. We just go around like that. Now it looks all good, right? You just might want to put a little pressure on it. You don't want to have the thread showing through it or anything like that, but you want it to be all nice and snug and things like that. Then what we're going to do is we're going to put it in here, twist it until it becomes tight. Then what we do is get a little pair of vice grips. Here's a little lockjaw plier right here, and clamp that on. Make sure that the direction you're going to be turning it into is this way. So if you're going to turn it clockwise, have it like this, so you turn it like that. If you have it counterclockwise, you turn it like this, so you have that leverage on there and helps out. I think I just got poked by a piece of glass dust. Okay, so have it like that there. This needs to be tightened up a bit. And remember, if you ever need to get extra leverage, do get a black iron pipe or something like that, just a steel pipe that you can do this with instead of having to fight with it. Just fighting with it's no fun. When you also you don't want to just pull down on it. You want to try and get take advantage of this fulcrum here. So you kind of want to just rotate it, not to push down on it, but to rotate it. And with this right here, as you can tell, it's a little small, so it won't go in there, of course. So you just get a bigger pipe, which is this 1-inch pipe right here. Don't need this piece of plastic. And you just put it in there. It goes really easy right away. Make sure you have enough clearance so you don't knock everything over in your path like I am doing right here. Oh, please don't fall over. Okay, there we go. Make sure you have a lot of clearance. Okay. Standard black iron pipe from Lowe's. It's more or less just navigating, make sure that everything does not get destroyed. Process, and also I think that's good enough right there because I don't want to destroy the threads or anything like that. That's pretty good. That's just fine. So now, as you can see, oh come on, Zoom's driving me crazy. Okay, there we go. Lighting's not the greatest, but anyway, we have that all done now. The gasket rubber is held right real well. Before, on the first one I was using another vise for the first of these. Ooh, I have to zoom out here. I was using a drill press vise for the first one to hold it in place because I already had this EPDM weather stripping I was using to hold a glass bottle in place. And as you can see, I'll have to open this up here for the camera to get it. As you can see here, it ripped it up pretty badly. So you want to make sure it's soft so that it doesn't destroy the threads, so it can absorb and cushion it. It also has a friction too, like rubber or foam would. But the problem with this rubber foam here, or something that's too soft, is it can rip it up and deform it, which you see right here doesn't look very good. So instead I just use that red gasket rubber, and that both accomplishes the cushioning and also it doesn't, it's still hard enough that it retains its composure under tension. It doesn't rip itself apart. because otherwise that'd be be losing your cushioning there. So I hope you enjoyed this. That's the first part, and later on we're going to get to screwing these things into the tanks or whatever, and going to show you how to put the tube in too. So that's this. Okay, well, the rubber failed in trying to secure this thing properly. It basically looks like a mashed up pencil eraser. So instead what I'm going to do is I'm going to turn off this. Apparently I can't turn the light off when I'm filming. Anyway, what I came up with here is this little rig. I was using originally a little C-clamp, not C-clamp. What are these things called? I'm using this type of vice grip here to solder my earth batteries and stuff. A similar setup with the drill press vise, so I figured I might as well try with this here. And I think it's going to work out really good. I was doing this by hand with just a pair of vice grips and a adjustable wrench by going like this, but this is probably more secure. I don't want to. It's really tight. It's really in there tight now. Instead, I want to fasten this down so it's a bit of a safer method of doing it. And as you can see right here, what it's going to do is it's going to twist both screws there. So I just have Teflon tape on both of them, as you can see here. And what I'm going to do is I'm going to just screw both of them in there. Because what happens is there's going to be less tension. If this was screwed in like really tight here, this would be the first one to spin if this was looser than this. So in the process, I end up tightening both of them. So what you need to do is just take an adjustable wrench, or better yet, another pair of vice grips would be probably nicer. And you can see that it's going to be a problem later on. You could also, take this off. I mean, this is adjustable wrench, so go like this right here. Just crank it like that. And remember, you're twisting both of these nuts here, so both of these fittings on. So it's going to take maybe not exactly twice the time, but it's going to take longer than if you were just screwing in one thread, because the other one's going to be kind of rotating as well. Ooh, that's what I was kind of afraid of, is that this thing would have been trying that on me. Good thing that I got that on video too, just to show you what the disadvantages of this here would be, and also I don't want to deform my vice grip. So I don't know. You're gonna have to find something to experiment with what works. Using something as a padding is good, but the problem is that if it's too soft, it'll just form and it'll tear up and eventually break itself apart, like this stuff did. And that's just a mess. Of course, the rubber worked for a little bit. I got this one on, but unfortunately it doesn't last too long. There's no point in going out and buying extra gasket rubber. So maybe you could do it like this. I suggest if you try and do it just free-handed like I did with the other one, I'm probably going to end up doing with this one here. I highly suggest you get 2 pairs of vice grips. And if you're going to be doing it clockwise, just do it like that. So that what happens is it goes like this, so the thing have that leverage there. This is just a pull here, and this is the real power right here. And this right here, like that. So you have all that leverage on it. And of course you gotta watch for this thing slipping, so that's why I recommend having a pair of vice grips instead of this, because this can easily, if this ever gets loose, so what happens is over time, depending on what kind of adjustable wrench you have, it might get loose and do this stuff and then just come off, and you could hurt yourself. So I highly suggest you use a pair of vice grips or something like that. And yeah, because you don't want this thing to slip off and smack you in the kneecap or anything like that. So I don't know, right now for this segment I'm unsure of what to do exactly for tightening these things. All I know is that it's going to take some experimentation. So I just wanted to include that note there so you knew not to, maybe not this so much. And also this vise here is kind of lopsided because of the way I fastened something in one time. It was completely screwed it up. This doesn't work so great. Clamping that into the vise doesn't work so great, and I don't recommend using this either. So you're going to have to find out what works for you to get this thing to work right. Okay, I want a quick show. Don't use the rubber at all, because all it did for me was just get a whole bunch of nasty residue on here, and it failed. And now, as you can see, it's just smooth and just flat, and the thread's completely been destroyed. So I'm going to have to throw this bulkhead fitting out and unscrew both of these fittings. So don't use the rubber at all. Here's what happened to it. One second. Here's what happened to it. Just completely deformed and destroyed itself. It's like a pencil eraser, basically. So don't use it at all. Yeah. That's what this gnarly crap does. So just wanted you to know, don't use it at all. Okay, in this video what I'm going to do is I'm going to explain where to drill the holes for these components, as well as how many holes to drill and things like that. I'm just going to explain in brief and then go on to the stages in more finite detail, but this here is just a bit of a explanation in brief of what to do. So this right here would be the operating tank, and for the operating tank you get a 3-gallon refrigerator bottle, and at the top you drill one hole. This was part of an experiment and didn't work out and stuff, so I capped it off. So basically on the top you would drill one hole in here, and you would insert a half-inch bulkhead fitting with the barb on the top. So you have a half-inch bulkhead fitting, which would preferably be right here in the center. And then on the bottom, you'd have a 3/4 inch bulkhead fitting and a half-inch bulkhead fitting. So that's what you would have here for the operating tank. Now the next tank here would be the first stage. I'm going to have a separate video for the drain tank and feed tank, so check those later on. Anyway, this right here is the first stage, and it has 4 holes on it. So you have 2 here on the bottom, you have 2 here on the top, and these little first hole I would probably want to explain here would be these are all half-inch, by the way. These are all half-inch bulkhead fittings, 2 on the top, 2 on the bottom. And this right here would be the ingoing tube, and you have a 2 barbs on either side of this bulkhead fitting that are screwed in, with the tube going up through the top right here. So the water goes up through the top and then rolls up, gets out of the top, and just falls down and collects on here instead of the weight bearing down onto the tube. I'll already explain that. Then we have the output tube, so that on the pressure cycle pushes it down into the second stage. So that's what this is for right here. And as you can see, it's as low as possible. I don't have a second fitting on the top of the thing like we do it here. Then we have a breather tube. So this right here would collect from the bottom of the tube. During the pressure cycle, this would push down. The water would be pushed up into the tube here at the bottom and make its way up into the second stage, which is higher than it. And it would go out through this tube here. So we have, and then we have the air tube here, which doesn't have another fitting on the other end, just only has 1 fitting on it. And this is just for the suction and pressure right here. So we got 2 bulkhead fittings with a fitting on either side. So we have 1 here, 1 here. And we have another 2 bulkhead fittings without a fitting on the inside, which would be this one here and this one here. So that's how this thing works. That's what this one is. Anyway, going on here, we have the second stage here, and I figured that it'd be better to drill 3 holes on the bottom this way rather than 3 holes on like here or whatever. Because the way I figured it, I already have a open air space for this, because this needs to be exposed to the air. This needs to be in the open environment. It can't be closed off, can't be airtight. So I figured, you know, I just do it like this, but I realized with the weight of gravity on the water here, it's a bit harder to push up, so you might just want to drill 3 holes here on the bottom and run the tubes up and stuff like that, instead of have it this way and this runs up like this. So run up like that instead of like this. You know, try things out and see if they work for you. Containers are cheap, and these can be removed. Sorry for bumping the camera. Anyway, you have 3 bulkhead fittings on the bottom, 2 of which have fittings on the insides, right here, and then they both have bits of tubing here. So one is an output tube right here, another one's an input tube right here, and that doesn't have a check valve on the end of it, and the one with the check valve is a breather tube, and that would run from the first stage up to the breather tube to the end here, and this is to prevent any backflow. So that's what that is. This is all open air. These 2 are not open air, these are both sealed off. The first stage and third stage. So going on to the third stage, we have 3 holes. We have 2 in the bottom, and we have 1 in the top. And there's only one with 2 fittings on either side of the bulkhead fitting, and that's because this is an input tube here. So this goes up through this tube here, and then we would go out through this tube, through this bulkhead fitting right here. This is the output, and this right here is for the air. So that's what this one is. And it's pretty much the same thing as the first stage, except it doesn't have a breather tube. That's what this here is. So that's how that looks. And then reservoir is the simplest one. It just has a bulkhead fitting with a barb fitting on it. All 1/2 inch, of course. The black ones are all 1/2 inch. Only the gray ones are, this gray one you see right here is the only 3/4 inch. So anyway, this has just got a 1/2 inch bulkhead fitting on it. I drilled a hole here at the top so that this would be exposed to the air, so this can fill up without bringing back pressure up through this tube, so that the water can fill up and the air that's in this container can go out through here. So that's what I did with this. You put a cap on it. And additionally, if you want to, you can also put a siphon or something in here, so that when it gets up to a certain height, it triggers a siphon and goes back down to the feed tank. If you're doing like a demonstration or something, and you don't want this thing to spill over or just fill up or do whatever. So that's what this one here is. Okay, so there's the introduction to it, and now we're going to go to a more detailed description. Alright, so here we have a more detailed description of the some of the more complicated tanks. As I explained before, the ones with the barbs going on the insides usually have tubes on them. You know, these kinds of tanks here where they have a barb fitting on the inside is usually because there's a tube going up through the top. So there's really not much to explain what the stage is. The only thing really explained here is the operating tank, and just to show you how to make this thing exactly, you'd probably want to caulk this up right here, just in case the vacuum gets broken through here or something like that. The vacuum or pressure gets too high in this tank, what'll happen is that the air might get sucked through past this little valve and break the vacuum, so we don't want this to be a point of leakage. So we have that there. This is a Blue Wave refrigerator bottle. You know, Bottle Depot Plastics Incorporated, so I guess Blue Wave is like a wholesaler or something. Anyway, this is a refrigerator bottle. It's like 19 bucks, 3-gallon size one for what we're going to be using. These are a 1/2 inch bulkhead fittings, so you have a 1/2 inch bulkhead fitting as the air tube, 1/2 inch bulkhead fitting as a siphon, and you have a 3/4 inch for the feed, so the feed tank feeds into here. And another little tip I want to give you, because that's what you got to do, is you got to take this thing and basically crank it till it stops. And I haven't really tested this thing yet, but if this thing still leaks, I would either put a fitting on it and with a cap or something like that, just like I did with this right here. Or what I would do is I would just I would open this thing up, put some caulk around it, squeeze it back, tighten it back down, fill this thing all up too, this stem from the inside here with caulk, to make sure this thing doesn't leak. This is not something you want to even have on it, because it's not even placed properly, so this can't be of use, this fitting here. You just want this to be sealed off. Alright, this right here is just, I was experimenting with having a different breather tube or siphon or something, and the tank was actually, this was supposed to be the top and this was supposed to be the bottom, according to the experiment that I was playing with, and I figured it couldn't work, because I kind of put a little more thought into it and realized it was a terrible idea. So don't bother with this, don't drill this. And the air tube would be best to drill right here. So this, if anything, would be better for the air tube, and this right here you wouldn't do at all. So you just have one hole at the top. So you have one hole at the top for the air tube, and that's it for this side. And other tip, final tip here for this operating tank would be to, there's a little plastic stopper that comes with this thing, so that when you normally use a refrigerator bottle, the thing would be set up like this. You have a little spigot for the Gatorade or water coming out of this thing, and this right here, you could pop this open and the air could go into this, and it would allow this thing to drain out a lot better. So it breaks the vacuum. It allows air to go in and keeps it from creating a vacuum. Well, you don't want a vacuum to be broken with this device, with an operating tank especially, of all things. So basically what you do is you open the thing up and you take a bunch of caulk, marine type of sealant caulk, that 5200 3M marine sealant. Open it up, put that stuff around it, push this thing back down in here and make sure it's all coated all the way around so you don't have any potential sources of leaking, and you just let it dry. And I recommend you get the fast cure stuff so you don't have to wait like 6-7 days for this stupid thing to dry. So that's it for the operating tank. Alright, I'm going to go over the description on how to build this operating tank. It's pretty simple. What you do, see if I have it marked in here. Nope. Alright, what you do is you basically get one of these tanks here. Want to make sure 15 quarts. Alright. And yes, yeah, it says 15 quarts here. Hefty thing came from Lowe's. You get a 15 quart tank. And drill holes wherever. It doesn't exactly matter. I did it the way I did here, and just remember that wherever you drill the holes, you also have to be able to drill holes into your shelf as well. So the way this lays here in the shelf is going to be the way where you put the holes at. So this would be here, this would be here, so it'd be kind of, across here and down here like an inch or two. Didn't really think this out when I placed this. So I suggest you just drill a hole here and drill a hole here, rather than have it like this. Whatever, doesn't matter. So anyway, this here's a 3/4 inch bulkhead fitting, and this here's a 1/2 inch bulkhead fitting. This right here, this siphon, this was supposed to be for like a, this is supposed to be the operating tank, but I couldn't get the seal and it turned into a feed tank. So that right there is not, by any stretch of the imagination, a siphon. That's not a siphon at all. That's on the cap. Alright, so this right here would be a 1/2 inch, this would be your 1/4 inch right here. Have a street elbow, in order to have an elbow, and this would go down into the, this would go to the drain tank right here, to the side of the drain tank. And this here would be the 1/4 inch street elbow, instead of having a, what is it, like a coupling or whatever, male-to-male coupling with a elbow and then another coupling and then a fitting or something like that. Instead, just get a street elbow. Saves you a lot, it saves you more money, more time, more hassle. So do that there. This right here would be a bulkhead, black bulkhead fitting with a 1/2 inch barb on it. This right here is an old version. I don't recommend you do this at all. I'd rather recommend just get something like this right here. So you have this right here instead of that. So you just replace the two. You know, replace this here with what you see right here on the bottom of this this output tube here. And of course, always remember to have some sort of extra sealant there, so I use that tape. Help keep the seal instead of doing this. And as for this feeder here, there's a little bit of a trick to it. In fact, this feeder, this is what this is. This is a, see if I can show you. I'm going to tilt up this LCD. Come on, LCD. Right here. This is a Little Giant. Oh. Right here, so this here's a Little Giant water feeder. It's an automatic water feeder for animals, basically. You get these things at Tractor Supply or Amazon.com, which I would recommend. So I'm always a big fan of Amazon. Things are a lot more convenient than going to Tractor Supply. But anyway, you get this thing for like 12 or 15 bucks. It's pretty cheap. And automatic water feeders made by Little Giant. Little Giant, you know, water feeder, automatic water feeder. And the fitting here is for a 3/4 inch garden hose, so you would need an adapter or something like this with a barb. Just right here, you can get this. I got this thing here at Lowe's. If you get it cheaper, I highly recommend it because Lowe's is like complete retail prices. This right here is just a. This isn't actually a 3/4 inch barb, but and it's oversized. What I'd recommend you do with this thing is you get the proper fitting for this thing, and in that case it'd probably be like a 5/8 inch barb for the 5/8 inch OD to this 3/4 inch OD tube. So the tube here is 3/4 inch on the outside, but on the inside it's 5/8 of an inch, and that's why you want to have a 5/8 inch barb to go with this. And this right here, the barb would be like 3/8 inch, because this is 3/8 inch ID, and this would be here would be a once again a 5/8 inch ID, a 5/8 inch barb for a 5/8 inch ID tube. I'm a little confused too. Sorry about that. Anyway, try not to knock over the Epsom salt over there. So anyway, this another part to this thing here. So you would just take the barb, screw that in there. Remember, this is for a hose type of fitting. There's a difference between a pipe fitting and a hose fitting. So you'll see like MH over at Lowe's. So it'd be a male hose rather than a male IP, you know, a pipe or whatever. So that's the difference is that there's fewer threads on this thing, and they're also bigger. So remember to get the right size. Remember to get a hose fitting and not a pipe fitting with this right here. And in order to anchor this thing down, because it has some set screws right here. In order to get past this little lip here, what I did is I just took a pair of scissors and I cut it, as you can see right here. I want to get the right angle. I have the LCD flipped towards me, so I'm like trying to play with this thing in my mirror image here to see how things are aligned with the camera. Anyway, so as you can see, took some scissors. If you can't find like a better way, probably get a Dremel or something like that, because as you can see, with scissors, you do run a risk of cracking it. As you see right there with that crack, that's not very good. You don't want to have to crack or anything like that. But do get some holes in here so that you can make contact with the set screws up against the wall rather than this right here, because these can easily slip off. You know, these little screws here, if they were anchored here, they would slip off. So make accommodations if necessary for this thing to compress up against the wall of the tank. That's all you need to really know for the feed tank. So we're going to go on to the next thing. Okay, in this video what I'm going to do is I'm going to explain how the whole drain tank and everything works, and explain how the function of the wire goes through, and how that depresses all the mechanisms and how things work inside of it. I'm going to explain where to drill the holes for this tank, and also how big the holes are, and also going to go and talk about the parts of this thing. So the first part of this video, I'm going to show you where the water goes in from this thing. The water enters in from the feed tank in through a tube that goes right here into this barb right here. Goes in and goes into a float valve, which is it's normal. This right here is an upside down float valve here. It normally has a little ball on the end of it for the flow and whatever, but for this purpose I've converted it to like a flow switch so that the flow of the water triggers it rather than the level of the water. So that's what this thing here is a little float valve. And it goes up through the float valve when the float valve's open. So, see right here. So as you can see, the plunger came out like that. That means that the float valve is open. And that means that since the plunger is pulled out of there, the water is allowed to flow from the feed tank up through this tube here into the operating tank. This flows into the bottom of the operating tank, is where this tube leads to. And what happens is when the this right here would be the siphon. When the operating tank eventually fills up with water, what will happen is that the siphon will get filled up. It'll go over the top of the siphon, trigger the siphon, go down through here, and this will be the end of the siphon right here. And don't know if you can see it or not, but right there, you see that little fitting there at the top? Right there is the end of the siphon. Now pour down into this tray here. When it pours down into the tray goes down like that, because what happens is this, I'll explain the mechanism later here, but the tray gets depressed, and when it gets depressed, as you can see, the plunger here is pushed inward, and I'll close off the circuit here, and the water will keep on draining through the action of the siphon out of the operating tank. So the water will keep on draining out of the operating tank through the siphon and keep this thing depressed. And as it keeps on coming out of this thing, it'll just create vacuum more and more inside the drain tank. It just keeps on draining out the operating tank without anything to replenish it from this tube here. So that's how that whole mechanism of the water works. And then the wastewater that comes out through this tray here, because the tray has a few slits in the sides of it that the water can drain out of. It'll just fill up in here and then go out through this tube right here on the end. And this tube can be hooked up to like either a condensation pump if you want to pump the water back into the feed tank for like a demonstration, or you can send it back to a river or something else like that in case you don't want the area around your Hydrautomat to get all muddy. So this right here is this will allow you to hook a hose up and carry the hose out to wherever you want to dispose of the wastewater. And going on here now to explain the actions and the mechanisms, kind of explained some of them, how this float valve works and whatever. The float valve's turned upside down, by the way. But as you can see, whenever stupid hole. What happens is when the this switch here is down, the float valve is closed, and when this is open, this is up, the float valve is open like that. And that's the action of the gate here. This right here is basically, this will be filled up with a little bit of weights too. This is to, it basically forms a weight that'll displace the counterweight. And as you saw on the patent, there's a lever, right? Well, I replaced that with a pulley system so that this right here, this swivel eye pulley here would be a, actually it's a fixed eye pulley, would be the fulcrum. And this right here, this little tray that can be filled with weight, with BBs or something to vary the weight of it. This right here would be the counterweight. So what had happened is this thing would normally keep this up like this. Right here, this counterweight would keep this pulled, be pulling down on the wire, and that would be pulling this tray upward. But what will happen is when the operating tank fills up and triggers the siphon will start pouring into that switch down there, and the switch will eventually become heavier than what this counterweight is. So what it'll do is it'll pull itself down, the counterweight will go up, and then what it'll do is it'll depress. So, and then what will happen is eventually the operating tank will drain out. There'll be no more water left in it to drain out through the siphon, or at least not enough of a flow to replenish this the weight in this thing, and the weight of this thing will go down. This will become lighter, and this will end up being heavier than the switch. And I'll just pull it back up into the open position all over again, and trigger the pressure cycle and fill up the tank. So that's how the mechanism works with this thing. And show you where the holes are to drill. First start off, we have a hole drilled with a hole saw here. I always recommend using a hole saw because it's a lot cleaner and stuff. I don't recommend using like a normal drill bit or something. Anyway, that way I don't, you know. But anyway, I would just I drill the hole here for a 3/4 inch bulkhead fitting. Right here, you have a hole drilled here. You have a hole drilled here, or wherever around the perimeter of the tank. Or if you want this drain tank to be located, you don't want this thing to be on the bottom, but you could have a shelf below it or something. So if you want to drain this down to something else, you could put this fitting on the bottom. It's all up to you. But I have this, the drain tank is the final, basically the tank closest to the ground, so I don't want this draining out to the ground, because you know, I have to drill through the bottom of the shelf and it's just going to be a mess. If that makes any sense to you. Anyway, this thing would be, this thing's usually drilled on the side, right here. We have a hole that's got a decent amount of room in it, so you could put a 3/4 inch tube in here, but you have a decent amount of space so that this thing can move around if you need to. And that'd be for the outgoing tube right here. Then we have a hole that's drilled for the siphon. And I would recommend just getting a bulkhead fitting and a barred fitting instead of this thing, because the street pipe's expensive. I was doing this for I had things set up a different way, and that's why it's going off like this. All you need to do is just get a bulkhead fitting with another barred fitting sticking out of it, and then drill a hole through the top of the shelf, and this thing can just run directly up to a siphon and then, you know, go into the operating tank. So that's all you need to do with this thing, is just have a siphon going from the operating tank, loops up where the feed tank is, comes back down, and then feeds directly into this. And the hole only needs to be as big as the fit the bulkhead fitting in, right here. And this right here, this would be, this is like a 2 by 2.5 or 2 by 3 inch hole. This is always drilled kind of, I would rather drill this toward the middle here, this hole. I would highly recommend drilling this as middlemost as possible to you know, this length right here. So like half this length, you know, this point here is where I'd have the center of this, and just have a little area for this wire to kind of move around. So in case it goes up or whatever, you don't have any, it doesn't catch on anything. You just have an open space for it to move around at. There's no potential hang-ups. So that's what this right here would be. Yeah, that's it for the holes. And let's see, what else? Oh, I guess we'll go into the parts now. So we just have normal bulkhead fittings and barb fittings. I would recommend using a bulkhead and barb fitting for this here. This doesn't need any kind of fitting whatsoever. Right here, I highly recommend you don't use a fitting, because you can just run a pipe up through it. This right here would be a bulkhead and barb fitting here. And have a float valve right here, turned upside down. You also have a coupling and a male pipe thread to a barb fitting here. But we could also do instead, because the way this float valve is constructed, you see there's a male pipe thread there that comes out of the top. You could just get a barb to a female pipe thread, and you don't even need to go get a coupling in that case. So you just put that on here. And this tray should be one of the more complicated things. That thing's supposed to let me get this thing out. Hold on a second. Anyway, the other two components to this device, took this apart so you can see it better. The first component would be just the counterweight, and this could be a box or a soup can or whatever you want, as long as it's kind of waterproof, that doesn't get corroded or destroyed by the water. You have a wire coming up through it right here, and you have a bit of a loop so you can clip it on to the pulley right here, so you can take it on. You can put it on, or you can take it off if you ever want to. You know, that makes it a lot more flexible in what you can do with this thing. You only just attach it if you ever need to move things around or take it off, like I needed to show you. So that's basically all this is just a you have a wire here with another ferrule, and then you have a straight one going up through and a loop right here. So that's all this right here is. And this is a bit more complicated. What I used is, I'm going to show you here what I meant by the slits here. Let me show you. That's what I meant by the slits right here. You can see how the wire can flow out if it ever needs to. So that when the wire falls into this tray here, it can just drain out through these little slits here, and you can adjust just by compressing things together just how much wire can come out at a time, or you can kind of open it up like that to regulate things. And as you can see, there's been no sealing or anything like that done, and that's just so it can drain out, and it also saves the work too. So that's why I haven't soldered this or connected in any other way. So that's all this right here is just a straight piece of metal that's been folded and cut. Preferably this right here would be shorter than this right here, so that the weight of the water, when this shaft is laying, at it was laying completely flat and level, what will happen is the wire will want to run down this little slope here and collect right here, so it'll build up in this part of the switch system instead of over here, because there's not anywhere near as much leverage here as there is over here. So that's why I have it like this. And just have put the shaft in. I have I think like a 10-inch shaft or a 1-foot shaft or something that I got here. That comes with the float valve. And I just drill 2 holes, centermost as possible, run through the length of the tray. I have a piece of Gorilla Tape here at the end to keep the thing from sliding off. See, it's kind of getting pushed off a little bit there over time. So you might want to put something else to better fasten it down, but that's what I use for the time being. And for the end of this thing, right here, trying to get the light here so you can see it, I just have 2 holes. Try and make it as symmetric as possible so you have the best balance on this thing. I just have 2 wire loops on here. I have it connected, have them crimped together by ferrule so they don't move around or whatever. I have this other little thing here to keep it from sliding within the ferrule in case there's any slippage. And I just have 2 wires here going up into this little clip so that they connect at the tops here. And at the same time, be taken off and removed and played around with if you need to. So you can take this off if you need to. And it hangs up like this, hangs as balanced as possible, and then you can clip the end of the pulley onto this end here. So that's how the switch works with the whole device. So I hope this kind of explained how everything works. That's how we have the whole device set up. And also, I also want to stress, try and get a wire pulley. Don't get one of the pulleys over at Lowe's, because what they do is they like to stop up and they're very chintzy. They're not very smooth. These wire pulleys are. This is a 3/16" cable, and I got that because what it said, the guy told me at the hardware stores, this was a 3/16". This is not a 3/16" wire. This is a 1/16" wire. So make sure you get a 1/16" pulley for your 1/16" wire, as opposed to this 3/16" pulley. And also make sure you get a swivel eye instead of a fixed eye like this one is. What it means by fixed eye is that if you clip this here, it wouldn't be able to move around. But a swivel eye, you could clip this here, and there'd be kind of like a there'd be a mechanism here that this thing could twist around freely with no problem. So that's the drain tank assembly, and that's how to make the thing. You know, you just drill some holes into it and insert the tubes and whatever, and it's a pretty simple device. Works very easily, and now we're going to go on to the next video. Okay, what I'm going to do here is I'm going to make a quick video about setting up the whole switching apparatus here. There's a little tray there in the bottom. A lot of the time, because of the valve and because of the float valve in the back, what'll usually happen is the float valve has some resistance to it, so that even if this counterweight here did have some weight and stuff in it that would automatically want it to pull down, a lot of times, because of the resistance of that, and sometimes like the pulley and some other stuff, what can happen is the thing can stall. So that even though there's enough weight here to pull that tray down, what happens is sometimes it might just like stop midway, it doesn't go the full way down, or when it's going up it might stall or something like that, and that's not good at all. So what you want to do is you want to make sure that the tray has enough weight in it so that this thing gets pulled up here, right, to overcome mechanical resistance, so that you don't have any stalling when the weight's going up. When the tray is being pushed down by the siphon, you don't want this thing to stall halfway or kind of like slow down, and the weight is still, and the valve is still open a little bit. You want it to fully close when this is going up, so you don't want any stalling there, and that's why you would put weight into the tray. And then in order to get this thing to rest in the default position, so that when there's no water going through the tray here in the bottom, the counterweight will just naturally want to pull the tray up and try and, you know, go toward the ground by force of gravity. So that normally sits like this. So you would then fill the tray up. After you fill up the tray up, you would then fill up this counterweight with some BBs or rocks or whatever else. I would recommend stainless steel ball bearings because they don't corrode. You know, it's not pretty when things corrode, and just it makes, and that's what that orange dusty residue is in the bottom of the tank, is the corrosion from these little copper coated BBs I was using, and they aren't very corrosion resistant, I can tell you that. So probably try stainless steel. That'll be your best bet. So anyway, you would fill this thing up with enough weight so that they'll pull that tray down with the weight in the tray. I'll just pull the tray down like this when there's no water in it, so that when the water drains out of the tray, this takes over, brings it back in default position until the operating tank fills up. When the operating tank fills up the whole way again, siphon trips, the tray starts taking on water along with the weight inside of it, and that causes it to pull back up again. So that's what you need to do in order for a for this thing to operate smoothly, is you need to put weight in both of them. And I would recommend putting weight in the switch there in the drain tank first before you put weight in this counterweight. And another little bit of advice, because you can see how this shelf is, it's got a little lip here. So as this thing goes down, you'll want to catch there on the top of the shelf, or it might catch here too. So what you might want to do is get a flat, smooth piece of plastic. I kind of bent it too, like this, so that it'll, you know, counterweight will just catch it like this and slide up and down. And that's what I want to do with this right here, so that it won't have anything to catch on. Just have a smooth surface. So I'm going to find a way, probably take like Gorilla Tape like I did with the other one, and just tape it on the back and fix it to this right here, so we don't have an issue with that. So there's another piece of advice, is make sure that this thing can't catch, and just probably the best way is get like a flat piece of plastic that's perfectly kind of bent like that, so it can just go off and slide off the thing. So that's the end of this. Alright, this here is going to be a quick video about drilling and how to deal with the shelves. I ended up accidentally deleting the one where I would show how to do that, so I'm going to do it all over again. Basically what you want to do when you drill these holes and whatever is to make sure that when you get a drill that has a little level gauge on it here, so you can hold this thing level like this. You can observe where the bubble is, and you can hold it at a direct or as close as to a 90-degree angle to the surface of the shelf as you possibly can, in order to prevent this thing from jumping. Because if the hole saw, for whatever reason, ever catches at an angle, there's a possibility that it can tear or rip the shelf up, and that's not very good at all. Another thing I wanted to point out, that you get an arbor that protrudes out of the rim of the hole saw. Because what happens is when you're dealing with this drilling here, you want to make sure that you can drill a hole that will help to center the hole saw before this hole saw digs into it. That also helps to prevent damage. Because just drilling with a hole saw alone, you know, with an arbor that has a short bit on it, you're basically drilling like this, and this can easily jump or catch, or it becomes a lot more difficult. Just want to point those few things out. And also, final bit here is when you're drilling, want to let you know that when you trace everything out and stuff, I highly recommend that when you trace things, which isn't hard, basically all you need to do is lay your components where you need to. And once you lay the components where you need to, just trace out underneath on the bottoms of them, you know, where you want to drill the hole. So you would just put this here on the top of the shelf, and then take a Sharpie or whatever and just go around the edge of the barb fitting or whatever it is. And then you can just put this in the center where that is, and then drill down. So that's not a hard thing to do. And when you're drilling the shelves, make sure that you don't have one shelf on top of another. So this right here, I don't exactly recommend you do. First off, I recommend that you start here from the bottom and just get this whole thing constructed here. Don't have this on top yet, so that when you're drilling, you can actually see where that level gauge is. Because if you can't see where this level gauge is, you're going to be in trouble. Because then you have a much higher chance of this thing getting at an angle, because you can't see exactly where this thing is in terms of being level, and it's very finicky with that. And you could possibly destroy your shelf. So make sure that when you're drilling this shelf, so say that you're drilling this shelf, make sure you don't have this on top of it. And then when you're done drilling this one, you drill this, you put this one on top and you drill this, and then when you're done with this, you just go in succession from there on out. And as for little square holes like this, you don't need to do that because you're using a Dremel, and a Dremel's not a big problem. Just remember when you're dealing with a Dremel, wear eye protection, and when you're dealing with shelves like this, you also have, see if I can show you, you also have a bar or a little bit of plastic a little piece of plastic to reinforce the shelf that runs kind of in a runs across. Let me show you just how it goes. There's a little piece, at least for this shelf, that runs like this, directly through the center of the width of the length here, and also to the width there's another piece that runs underneath like this. I'll show you where it is right here, because you're going to have to drill through that as well. I'm going to stop this camera with this getting a little distracting. There's a piece right there, and then it just goes across to here. Can't exactly see it because of the camera angle, but that runs all the way through the length of this thing right here. And a lot of times the cutting wheel on the Dremel or whatever you're using, I highly recommend you do not use a razor blade, because the razor blade can jump, and you can have just a straight you have something that, there's a straight cut going out the middle of nowhere that's not anywhere near part of what you want to cut, and as this thing, wears and stuff like that, you can end up cracking the shelf, and that's what happened to my last Hydrautomat. So I recommend you don't cut anything. I recommend you use like a saw or something like that. Anyway, the cutting wheel, the Dremel usually does not reach all the way to the bottom of this thing, so you have to usually go and you need to go to the go underneath the thing and then cut it from the bottom side up. Cut what's left of it. So just want to point all that stuff out. That's how you would cut the holes and things like that for the Hydrautomat. Okay, so now we're going to do a just an overview, concluding this segment of where everything's going to go. These two are going to be for the drain tank here. The siphon is actually going to run underneath. At least for my version, it's going to run underneath because I have just an elbow, so that this right here is going to go on the top of this tank, and this tube can slide underneath here to go out through the side and connect to the operating tank. So that's how this thing can go. Anyway, so we have this right here. This will be for the pulley, an opening for the pulley system to go up. We'd actually have another hole right here someplace, just the same dimension roughly, so that'd be kind of shoddy, but this right here would be for the pulley as well, and this is where the pulley would tie in. So there'd be one wire would go up through here and just wrap around through the edge right there. So this thing here would basically go around like this and around that hole, and you tie it off. This here would hold the pulley. This is a little clip here, so you could take the pulley on, pull it, take it off. And that's what that would do right there. And this right here would be the operating tank. These two holes here, so this would be for the siphon, and this right here would be for the feed tube. This would be the tube going into the drain tank. Then through this tube right here, this would go up here. And this other part here would be the input, and this would lead into the feed tank. So what happens is the feed tank, wire go down through the feed tank, go up through here, out through this pipe, and into the operating tank through this hole right here, and also out through the siphon through this hole here. Anyway, they're on top of the operating tank. Like I said before, this is just useless right here. This is not part of the Hydrautomat. This is just another concept I was messing with. This right here is the air tube. This is part of the Hydrautomat. So this tube right here will go upward. Alright. Preferably out through here to avoid the feed tank, because the feed tank's going to be this giant bulky thing. And air tube will go up through here. Go up through here as well. Through this hole here. I have it drilled here, unfortunately. Might want to make a hole right here. This is where I recommend you drill it, because you already have a hole here in the corner, so why have it over here? So anyway, you have the tube go up here. You have a T, so part of the T would be facing here as well as here, so you'd have it like this. So you would have the tube coming up, have the T split here, and middle of the T would lead around and go to the first stage. First stage is the air tube, which is right here, and the first stage would be hanging about right here. That's where this would be. And second tube, second part of that air tube would lead up through here and go in here to stage 3. So have that there, and what else? Anyway, have the feed tank here. These two holes are for the feed tank. This would be a 3-inch, this would be a 2-inch. The air tube only needs to be 1 inch, although I just took a 3-inch hole saw where I was supposed to drill them and forgot about the differences in the sizes, and I just had a 3 inches the whole way through, and you don't need this. I mean, this is going to be a 1/2-inch tube, 1/2-inch OD tube, outer diameter tube, going through a 3-inch piece. You don't need this. But I already drilled it, and I'm not going to plastic weld the thing back in. So it sits as it does. This needs to be 3 inches or 2 inches, whatever the size, whatever the bulkhead you're using, whatever the diameter of the bulkhead that you're using is, this needs to be bigger than that, so that this can fit in very snugly. This would be a 2 inch, as it is on mine. If you use just use all black bulkhead fittings, this here's going to be a 3/4 inch bulkhead. Bulkhead for a 3/4 inch OD fitting, so you probably need a bigger one. But for the one I have with the 1/2 inch, 2 inches is fine with these guys. And with these giant gray ones here, as you can see, that 3/4 inch one, I need to use a 3 inch wide one. So this right here is for the feed tank. This is for your pulley. This is for an air tube. This should be 1 inch rather than 3. This should be another 1 inch right here, and I have it in a dotted line pattern to show you where it should be. These 3 right here that I drilled are all for this stage 2. I have this underlined to show you. This right here, you don't need. This is for the air tube where I drilled it, although it should be right here, and that's where I suggest you do it rather than here. And the air tube does not need to be 2 inches. It only needs to be 1 inch. There's no reason for that extra size. Anyway, this right here, these 2 are for the first stage. So you have the breather tube, which would be right here, and you have the air tube, which would be right here. Or it could be the opposite way. I mean, it doesn't matter, because the air tube is going to lead over to here, and the breather tube is going to, you might have to drill another hole for the breather tube, because what's going to happen is that spout is that fitting, the bar fitting is going to be standing up like this, and the tube's going to have to go to the bottom of this tank here. So you might want to drill a hole here, or even thread it through all the way to here, or run it back through the same hole where this thing is, and then thread under here, or just drill a hole right here, have the air tube right here, and then have this breather tube go down in here, then loop around, and then go up into where the breather tube is sticking up, about, I think, here or something. Then you have it connect there at the bottom of the S2 tank. Anyway, so that's where we have these. And as you can see, this would be the stage 3. Got a 2 inch hole here for the bulkhead fitting, and you got 1/4 inch holes here that are just big. That are big enough for the wire to sit in. You don't want them too big, because you just want the wire to come through. You don't want it to be really tight. That's a hassle to pull it through. But you want it to be big enough that you don't want it to be small enough that it holds onto this thing. Anyway, just drill 4 holes around it. Try not to compress, try and grip the edges of the tank. I have these made, didn't point this out before, but the way this is made, kind of, you see how these corners are? That's why I have the holes drilled on the sides of the thing here. I'll show you firsthand. That's why I have the holes back here rather than up further, because what they do is when you run the wire over the top, the wire sticks right here, and if this thing ever wants to move around, you have this wire sitting on the top, so you have resistance here. It would have resistance here, so it doesn't want to move either way, because the wires are holding it down and keeping it from sliding around and coming loose from the wires that are holding it. That's why I have these drilled behind this little crevice, or whatever you want to call it, this curve here, corner, whatever you want to call it. That's why I have it drilled like that. And I have the air tube here. Once again, it only needs to be 1 inch, not the 3 inch thing that I drilled here. Or actually 2 inch, not 3 inch, but 2 inch hole I drilled here. It only needs to be 1 inch for the air tube hole. And or maybe it needs to be 2 inches, because you got two 1.5 inches or 2 inches or something. So you can have 2 1/2 inch OD tubes coming up through here. So one would go to the air tube, another would be from the S2 tank pumping water up into the reservoir tank, up through here and touching the reservoir tank, which would be right here. And you got the 4 holes drilled right here. I'm probably going to have to make some plans up and stuff like that. But as you can see, that's how these guys are arranged. And I'll probably take some take some pictures too before I put all the components and stuff together, so you can see how everything looks. So this will kind of serve as a blueprint here. Anyway, that's the overview for right now. Okay, as you can see now, we have the Hydrautomat fully assembled here, and now it's fully assembled. There's only a few things left to take into mind when you're building this thing. The first one would have to be the check valves. Always remember to have a check valve on the tubes conveying water from the feed tank, going to the first stage, going to the second stage, into the third stage here, and then into this reservoir. Always make sure that you have a check valve on it in order to prevent any backflow. So you have the check valve pointing so that it'll only open up going towards where it's supposed to go, and that way it'll prevent any backflow back into the tank that it came out of. So as you can see, we have all the check valves here and stuff. They'll have hose clamps on them. Each and every barb fitting, I recommend that you put a hose clamp on to prevent any potential leaking, because that'll easily cut down on the performance of your device, and that can even cause the tubes to pop off, because that's happened to me a few times with the automatic water feeder and the drain tank tubes. There'll just be so much water flowing through them that they'll actually pop off from time to time when I don't have any hose clamps on them. So I went out and got some hose clamps, and that problem has been solved. So always make sure that you have some hose clamps on your fittings. Make sure they're not too tight, because you might basically destroy the might squeeze the tube too much and kind of destroy the tubing. So you don't want it to be too tight, yet at the same time you want to be able to prevent any leakage. So always recommend you get that on a barb fitting. Another thing I want to point out after the check valves would have to be, if you want to kind of make this tube here shorter, because as you can see, like the tubes leading out of the first stage right here, this thing goes right through the feed tank, and the reason why is that if I cut it down to the point that I wouldn't touch the water in the feed tank, if this thing was full, the hose would kink. So if I had too short of a hose, the hose would be kinking on me, and that's why I ended up having it nearly touch the bottom of the feed tank here, just because I didn't want any kinks out of this thing. And if you want to get around that, the easiest way to go about doing that is to replace this straight barb fitting here with a elbow barb fitting. That it's basically a barb that goes like this, but it also bends at a 90-degree angle, and you can just have that, shoot the tube out horizontally and then into this right here, instead of having to go straight down and slowly curve its way up into the second stage right here. And same thing for the third stage. As you can see, this tube here goes a long distance all the way up to here into this reservoir tank, and as you can see right here, this would also need a elbow fitting, which I would highly recommend using an elbow fitting for this tank here, because as you can see, just the weight of the hose is pulling down and constricting that thing and nearly kinking that tube right there. So if you replace this straight barb fitting here with an elbow barb fitting and just ran it out to the side and just straight down through here, you won't have the you won't have to worry about this thing kinking like that. So there's another thing I wanted to point out for this device. And third thing, or fourth thing, whatever I'm on, do that. I just flip the LCD around. Third thing is to make sure that when you have an input tube here, which this would be the input for the garden hose, so I'd hook up the garden hose to this adapter here, then I'd go to the tubing. Always want to make sure that you either have this thing hang over the top of the shelf, Or like I did, I drilled some holes in the shelf. So I drilled one here in the front and one here in the back, and then threaded it into the automatic water feeder, so that this tube here, at least part of the tube, will lay on this shelf here, and the shelf will bear most of the weight of the garden hose and the watering hose and the tubing and stuff. All that weight is going to be transferred in large part to this shelf here. So that will help prevent any stress or whatever on this fitting here for the automatic water feeder. Because what will happen is if you had this tube running underneath this shelf, just running directly to this fitting here, and it wouldn't sit on top of the shelf at all, if you had that happen, this barb fitting right here, imagine this would be the barb fitting, what would happen is the way the hose would just want to pull down this thing and either kink it or even pop it right off the fitting. So that's why you want to have this thing lay over the top of the shelf. And that's about it. So hope you enjoyed the whole how to make your own Hydrautomat series. Very much look forward to anybody's improvements, or you know, at least, you know, even just replications and stuff like that. Always like to see what other people have for ideas and stuff, you know. And you know, hopefully together we can make some better devices out there and help out the world.